So I'm going to talk about software. Oh, I should be here, right? I'm going to talk about software that I use for teaching. I've used it for a couple of years, and it involves Python and Markdown. So if you want to follow along, this is exactly how I do it in my lectures. So you go to pyintro.org. You can do this. You don't need a laptop to do it. You can do it in your smartphone. Go to pyintro.org, select lecture, and then lecture 1, and you'll be able to follow along exactly what I'm doing. So who should care about this? If you teach a course of any kind, it could be a workshop or something like that, especially if it involves programming, you might be interested in this. If you want to add interactivity to a course where you want to interact with students, you might be interested in this. And if you want to use Google Sheets as a database, that sounds silly, but I'll talk about that. You might be interested in this. And if you want to just use Markdown and Python for everything, which is actually you can do it. Everything here, the website, the course, everything is done in that combination. So you could do that. You'd be interested in this. So let me give you a short version for those. This is going to be cryptic, but if you're an expert in Python and websites, this might make sense to you, but I'll go into details of some of this stuff. So the software consists of 3 parts. There's a parser. So it's a command line thing. You give it a Markdown file, and it'll convert it to HTML and JavaScript. So that's based on something called Mistune. That's a very fast Python Markdown parser. And I'll show you that you can actually use it to edit Markdown with what you see is what you get type of interactivity. So this basically generates a static website just like Jekyll and Sphinx. Many Python people have used Jekyll or Sphinx. So it generates a static website, but it adds interactivity and teaching-related stuff. There's a server, and it uses Tornado. There were several talks about Tornado earlier on. It's a pretty nice, simple web server framework. And the nice thing is you can actually make your website using Make, or you can go in and use a GUI to edit the static website. I started this project originally to create a learning management system without any database and without any web server. Okay? The idea was you run the parser, you get HTML and JavaScript, it would communicate directly with Google Sheets, and it'll store all the data there. And you don't need a web server, you don't need a database. And actually you can deliver lessons that way. And actually it works that way even now. But there were a couple of problems with it. One, it was too slow. Google Sheets took 2 seconds for each transaction. So what the web server does now is it comes in between and makes it much, much faster. It just caches it. So it's really fast, and every 2 seconds it dumps the data to Google Sheets. So it's saved. And also, on a smartphone, for example, it's not easy to look at an HTML file if you think about it. You can do it on a desktop, but smartphone, you need an app or something like that. So you need a static web server to actually look at any HTML file. So the original idea of doing everything without a web server didn't quite work. You can still do it, but it only works on a desktop. But it provides a very different framework from the standard database, web server framework, and so on. So if you're interested in using Google Sheet, you can actually use it. You just need something to speed it up. And a lot of the data I save it with either Google Sheets or Dropbox as files. So everything is automatically backed up. The stuff I delete by mistake, I just go back to revision control on Dropbox or Google Sheets. I just bring it back. So the thing is very safe that way. As I said, the database it's not written in Python. It's a Google app script. It's a few thousand lines, couple of thousand lines. It's JavaScript and just resides as part of a Google Sheets database. The source code's on GitHub. The nice thing is pure Python, and it has almost no dependencies. It's all self-contained. The only thing you need to install for the basic stuff is the Tornado web server. It's not that highly documented. I've been using it for 2 years, but it will require a fair amount of hand-holding if you want to do it for an actual course. If you just want to use it as a Markdown parser, it's very easy. You just download it, and it's a command line program. You can use it right now. So any of you use learning management systems if you're young enough? Okay. It's the stuff in your university where you log in, you see a grade, you see the instructor uploads course material, and those are big things. The billion-dollar companies that make these. The main ones are Blackboard Learn, Canvas is an up-and-coming one, Desire to Learn, Moodle, and Sakai. Those are the main learning management systems. It's interesting to look at the architecture of those systems. Moodle is an old one, and these are the open source ones. So Moodle is actually the standard LAMP, Apache, MySQL, PHP type of thing. So it's very old, it's PHP based. Sakai is Java based. Canvas is one of the newer ones. It's based on Ruby. And there's another one called OpenEdX, which is, some of you may be familiar, it's developed by MIT and Harvard. It's basically geared towards online courses or MOOCs. It's not used for regular courses yet. But that actually is based on Python and Django. So that's only Python-based LMS that I know of, and it's not a very general purpose LMS yet. And it's a very sophisticated and big project. So my stuff is a one-man project, but it does a fair number of things. So using a learning management system for teaching programming, I teach Python to undergraduates. I'm teaching it right now. I'm in the atmospheric science department. I'm a climate modeler, so I use Python for data analysis, and I also teach it for data analysis to our students, meteorologists mostly. And using a general learning management system, it's not very programmer friendly. So this is the reason why I do this, why I developed this. So this is a LMS that's Markdown based. It's very code friendly, as Markdown is. It's also very version control friendly, which means if you make a change to your course material, you just change a few lines and you can see what lines you've changed, which is a very nice property to have. If you're doing it with PowerPoint, for example, you don't get that property very nicely. The other thing is you can combine slides and document views very easily. I like to navigate quickly in my course material. You can extend it. It uses Culp, which is a browser-based interpreter, so you can have interactive exercises that people can do. It automatically grades coding exercises. That's why I don't want to grade coding exercises, so it'll automatically grade it. I'll show you an example of a fill in the blanks using code. And it also plays nice with Jupyter Notebooks, which not quite Markdown, but you can do one-to-one mapping between Jupyter Notebooks and the Markdown format. So it can import and export Jupyter Notebooks. So Markdown, in case you're not familiar with it, it's a very simple markup. And the goal is it's easy to read and easy to write. And I'll show you an example of Markdown in a moment. And that's why I call it Pythonic. The reason I like Python is it's easy to read and easy to write. It's sort of minimalist. And Markdown has the same property which XML and HTML, for example, don't have. So that's why it is popular. There are various flavors of Markdown. Anybody uses GitHub, you create .md files, those are your Markdown files. It's used for R statistical programming. There are all kinds of parsers in various languages available for Markdown. So it's pretty widely used. There's some downsides to Markdown. It's poorly standardized. It's sort of a very cryptic original document. The attempt to standardize it, it'll always be limited because that's the goal. It's supposed to be simple. And things like embedding images, it's messy. And there's workarounds to it, but it still is not as simple as PowerPoint where you can drop an image and annotate it. So here's an example of kind of interactivity I have. So if any of you are logged in, any of you are logged into this? Okay. So then you can, I'm going to make it interactive. So you can, I ask students questions like this. What is your favorite Python web framework? In case you don't know any of these, you just pick one randomly and select it. And if you have a smartphone and if you have a Twitter account, you can actually tweet your answers too. So if you want to tweet your answer, use this format. You say @pyintro space the option you want, like A, B, C, or D, and then a sentence that tells you why you're picking that option. So if you do that, any volunteers? Go ahead and do that. Just, did you type something and send it? Okay. Let me see. Oh, it didn't come through. Oh, there it is. Okay, so this is what you get. So if I have a class of 50 students, all their names pop up as they respond. And here I've disabled the login, so anybody can log in, but usually at Texas A&M, we have Google for the whole campus. So it's restricted to @tamu.edu Google logins. and there's a roster for students, only students can log in. But I disabled that for this. So as students log in, they can respond to these questions, and I have a timer, and then I end it. And then I can view all the responses. So I say done. So these are the responses from students. So you can see, you get interactive polling from students, and actually you can see each person's explanation for why they picked an answer. So you get more than just a multiple choice response. You get the rationale for choosing different choices. So let's look at one more question. So these are two examples I have here. And this is where I have fill in the blanks for coding. And what you see here is a simple function students have to write. So it's a defined area of a circle. It has a function, it's a function with one argument, and you need to fill in this. So let me try to put in something here. I can put in 3.1416 star. Students do things like this. They'll say, you want, sorry, it's 2.5 squared, yeah. So you want square 2.5, they'll directly copy 2.5 here and try to square it. And you can run a check on it. And so you can cheat because you can put the answer in the return. So the first test succeeds, but the second test fails. So you can have multiple tests. And so let's put in the right solution. Run the check again. So you can see both the checks succeeded. And then I answer. So this is what the student would do. And there are actually hidden tests that the students see, which is run when they hit answer. So it could handle things like corner cases. So students can be penalized for not handling corner cases. So in this case, all the checks pass. And so this is automatically graded. So I don't have to go in and look at the code. And the nice thing about fill in the blanks is it provides scaffolding. Students often have trouble just putting defs and returns. But so you can gradually increase the complexity of the questions with this fill in the blanks, and you can go to full code. You can also do full blank code in this and have checks to grade it. So the front end, as I described, is basically HTML and JavaScript that's generated by the parser. We do a lot of math in our courses. There's something called MathJax, which allows TeX or LaTeX formulas. And this software called PageDown, which renders Markdown in the browser. And some of you may have used something called Sculpt, which is basically a JavaScript implementation of the Python interpreter, which runs in the browser. And that's how the code is checked in the example you just saw. And so the input formats can be Markdown, PowerPoint, or Jupyter Notebooks, but you can actually read PowerPoint and convert it to Markdown. If you have simple images, it works. If you have complicated annotation, it doesn't work. The back end is Markdown files and Google Sheets for student responses. The web server is Tornado-based, and it supports Google authentication and Twitter integration, so you can actually respond with Twitter. If you don't want, you can just actually text your message to 40404 and you can tweet. And the way this works is for each course, there's a separate process that runs. So if there's a problem in one course, it doesn't affect the other courses. They're basically clones of each other. And there's a proxy which decides which process gets the request to handle. So the way the course is published, a static site is generated just like in Sphinx, and the proxy speeds it up. As I said, Google Sheet, it works, but it's a bit slow. And you can either create the website for the course using command line, using make, or you can use browser and click things to do it. So the command line works if you're making a wholesale change. You don't want to click lots of things. And the browser one works if you're making instant changes for small parts. So I use both of them depending on the situation. So the lessons learned. So Markdown can be extended for teaching programming with interactivity and auto grading. So that's the whole purpose of this. It saves me a lot of work. It took a lot of work to write this, but it's a 10-year investment. So hopefully it'll pay back on that. And the parser combines slide and document views. I haven't shown you that. I'll show you that in a moment. So this is a slide view of any document. So if I press escape, this was full screen view. So I'm going to normal view. It's not full screen view. It's still a slide view. So if I get out of the slide view, I get what's called a document view. Now you can see the whole presentation as a scrolling document. So this is exactly the presentation. So escape goes back and forth. And in the document view, you can do this. You get an outline view. So here's the sample question that we did, so you can see that. And if you want the last slide, you can see that. And at all times, you can switch between slide view, document view, or collapsed view. So it's very convenient to navigate. And you can also go between slides using the title of the slide. So if I want a particular slide, I just go to the slide. So it makes it very efficient when you're teaching to going back and forth between slides. And a few more minutes. So let me show you how the Markdown looks for these things. So this is the actual file that I used for the presentation. So I'm pretty old, and I use Emacs for editing. I don't know if anybody uses Emacs here. Okay, you get still still alive. Yeah, I started programming in 1975, so that's a long time ago. But if you're using Markdown and Emacs, you might find this useful. So the way I edit my presentation is, so this is my PyTexas folder. There are two files. There's a Word document I use to submit the CFP. And this is the presentation file in Markdown. So when I edit this, what I do is I run my parser with these. Let me see if you can see the options. I give the name of the file, and this is pasting. There are different kinds of pacing, and I used instructor control pacing here, so because I control what you see. But I reduced the pacing to no instructor control here, and I specify a port. And what this does is it generates the HTML for Markdown and opens it up in a browser. So this is, and so the nice thing is I can edit it live in my Emacs. So I can change things here. Let me change it here. You'll see it. So you can see as I edit here, and every time I save it, the view here changes. So you can use any editor. And so all this parser does is it runs a simple, the built-in Python HTTP server. I forget what it's called. It's called HTTP server. And it just polls the file for any changes. Every time you change the file, it'll change the view. And it also remembers which slide you're on. So if I change a particular slide, let's go to open source. Yeah, if I change it to, if I remove Ruby on Rails and change it to Ruby, you can see that will change there right away. So it remembers which slide you're on, so it'll automatically update that. So I think I'm almost out of time. I'll stop here and take questions. So this is what the file looks like. Oh, there's one more thing I forgot. What do those fill in the blanks look like? This is what they look like. Yeah, let me make it bigger. So all I do is I say it's a fenced Markdown code. I say it's fillable. And then things that need to be filled, I put in double backquotes. And they automatically disappear. And it keeps track of the right answer. It'll test you for it. So you take any piece of code, you put this double backslash, and it makes it a blank for students to test it out. And these are the tests that are run on the code. Thanks. Yeah.
If a student clicks view source, can they see the hidden tests?
View source.
On a web browser, because you're running sculpts to the browser side.
Yeah, this thing is not NSA type of security. It's for people who, you don't want it for high stakes exams or something like that. Yeah. A view source for, yeah, they can hack the JavaScript. That's true. You can't really, if it's browser based, you can't really, if it's Culp, you can't really avoid that. You can obfuscate it, but you can't prevent it. Yeah. And let me show you this is the, I said Google Sheets. This is what the Google Sheet looked like after this class. So you can see it's automatically updated. You can see all the stuff, all the people who, you can see all the answers too. They all appear in the spreadsheet here. Any other questions? Okay, thank you.
Thank you.